So today, we'll talk about the properties of logs. Properties of logs. And because we think of a logarithm as being an exponent, they share the same properties as exponents. So just let me run this by you. If I had x cubed times x to the fifth, what do we do with the exponents? We add them. So our first property states that if you take a log, any base, of two numbers multiplied together, let's say m times n, what we can do is split them apart, and that would be log base b of m plus log base b of n. Okay, and I'll give you some examples of that. Let's say that we have log base, well, let's take any base 5 of xy. And we want to write that in expanded form. I can write this as log base 5 of x plus log base 5 of y. So it's really that simple. Okay. How about I'll give you a real simple example here. Log base 2 of, let's say, 32. All right. We really wouldn't need it here. What's the answer to that? What's log base 2 of 32? What does that equal? 5. Right, 2 to the 5th power is 32, so it's 5, okay? However, I can write this way, just to show you how the property works. I could write it as log base 2 times, let's say, 8 times 4. That's 32. Using the property, I could write this as log base 2 of 8 plus log base 2 of 4. And what's log base 2 of 8? 3. Log base 2 of 4 is 2. And 3 plus 2. Okay? Just to show you how the property works. We have another property that says find log base b of two numbers divided together. What do you think we're going to do with the logs? Subtract. Because when we divide and the bases are the same, we subtract exponents, don't we? And, all right? And logarithms are exponents. So log base b of m minus log base b of n. So that's two properties we need to memorize. The whole section today has to deal with properties. All right, let me give you an example. I'll get this out of the way here. Given that log, make sure I get this one right. Given log base 3 log base 2 of 3 is equal to 1.580. That's given. And that's going to be, that is actually true. Log base 2 of 3 is actually 1.580. Okay? And it's approximate. We've rounded this. So this is an approximation. By the way, these logarithms are non-repeating, non-terminating decimals. They're irrational numbers. Okay? All right. Find log base 2 of 12. Find log base 2 of 12. And use the given information. Okay? Now, how can I write 12 with using log base 2 of 3? 3 times 4. So I can write this as log base 2 of 3 times 4. Using my property, log base 2 of 3 plus log base 2 of 4. What's log base 2 of 3? Given 1.580. What's log base 2 of 4? 2. 2 squared is 4. And so 1.580 plus 2 is equal to, and these are approximations, 3.580. That means if I take 2 to the 3.580 power, I'm going to get 12, or close to 12. So that might be one of the ways that we can use that. Follow that? Okay. How about this one? Find log base 2 of 54. What can we do?
We're still using the given log.
We're still using the given.
Divide that by 3.
Yes. And what do you get, 18? So you want to make this as log base 2 of 18 times 3?
No, yeah.
6 times 9? Is that going to, no, not 6 times 9. All right, this is a little bit, we got to be, sometimes we have to be a little bit creative. Look. 3 times 3? 9 times 3? 9 times 3 is 27. 27 times 2. Because I want to write everything that I know. And so I'm going to use log base 2 of 3 times 3 times 3 times 2. I know what log base 2 of 3 is. And I know what log base 2 of 2 is. What is log base 2 of 2? 1. Yeah. So, log base 2 of 3 plus log base 2 of 3 plus log base 2 of 3 plus log base 2 of 2. Okay? So you have 1.580 plus 1.580 plus 1.580 plus 1. Okay? Similarly, if you wanted to find log of base 2 of 3 halves, 1.5, using the given. Log base 2 of 3 minus log base 2 of 2. You get the idea on how you do that? Because there's a whole section there where you're going to have to be a little bit creative. They're going to give you a bunch of givens. In fact, let's turn to page turn your homework to page 382. Page 382. And you can see on that, I think in my book it is highlighted in purple. Same with yours? Okay, so it's highlighted in purple. And they say that log base 2 of 7, they give you log base 2 of 5, log base 4 of 5, log base 4 of 3, log base 2 of 3, and log base 10 of 8.3. And you're going to use that information to come up with these numbers. For instance, log base 4 of 15. Well, you can use log base 4 of 5 and log base 4 of 3. 5 times 3 is 15. And that's using these first two properties. Right? There's about 5, I believe, properties. You okay with those? All right. I'm going to write down the first two properties again. You don't have to rewrite them. Log base b of m times n is equal, when you multiply 2 or 3 or 4 things together, we can write it in, this is called expanded form, log base b, any base, of m plus log base b of n. That was the first property we had. The second property we have is log base b of m divided by n, which we subtract the two logarithms. The third property, tell me this, what if I had x cubed, in parentheses, raised to the 5th power? What do you do with the exponents? Multiply. All right, so that's what this property has to deal with. Let's say m raised to the a power, to some power. Okay. So we're going to multiply. We're going to take the a, and all we do is bring it out front. This property says it is a times log base b of m. Okay. Hey. Okay. So those three properties. Let me show you some of the problems you'll have. Write in expanded form log base 3, take any base, of x cubed y squared over z. And write that in expanded form. And we're going to use our three properties here. This involves all three properties. So we have log base 3, and I'll do this in steps, x cubed plus log base 3 of y squared minus log base 3 of z. You understand where I'm getting the pluses and minuses from? Using your properties? Okay. Now, because I have an exponent there, I take the 3, bring it out front. It becomes 3 times log base 3 of x plus 2 times log base 3 of y minus log base 3 of z. And so we've taken a logarithm written as a single log and written it in expanded form. Then we're going to have to go backwards with it. Okay, we're going to take one and then go the other way. Take one that's written in expanded form and go back to write these as a single logarithm. That gets you used to using these three properties of logarithms. All right. Think of this one. What is log base 2 of 4 to the 5th power. How would that be? Let's use that property, that third one we just did. Take the 5 out front. Can anybody think of what it's going to be? 10. It's going to be 5 times log base 2 of 4. And we know log base 2 of 4 is 2, because 2 squared is 4. And 5 times 2 is 10. So 2 to the 10th power is equal to 4 to the 5th. So another way that we can use that property. All right. Here's another property. Take the log any base of b to the x power. What does that equal? Take the x, bring it out front. What is log base b of b? 1. X times 1 is x. Okay. So in other words, if I had log base 7 of 7 to the 5th power, the answer to that would be 5. The answer to this is 5. 5 times log base 7 of 7. Okay. There's another property too. I'm not going to go through the explanation, but it looks like this. Some number, any number b, raised to the log base b of x is x. An example might be 4 raised to the log base 4 of 18 is 18. So just recognize that property. All right, and you'll get some practice problems involving those properties. Okay. One final example. Working with logarithms. I'm going to leave this screen up here so you can see the properties. We have about 5 properties to memorize. Some of these can get a little tricky. That's why I decided to, for those of you listening at home, that's why I decided to push the quiz back. Our quiz will not be on Friday. It will be next week. If you have log base 2 of x, and that equals, this is an equation, log base 2 of y, if that's a situation, Blaze, if log base 2 of x equals log base 2 of y, then what do you think? Then x equals y. All right, that's pretty simple. If you have 2 logarithms equaling one another and the bases are the same, we can just compare what they're equal to and then go ahead and solve it. For instance, you might see something like log base 2 of 3x equals log base 2 of 7. That means 3x equals 7, x equals 7/3. Okay, does that make sense?
You can just take the log.
Yes.
What if there's 2, like log 2 3x plus log 2 4x equals log 2 7?
Oh. All right, I'm going to go to another screen. I'll come back to that one. What if it's, go ahead, log base 2 of, what'd you say?
I said 4, I think.
4.
Plus log 2 of 7 equals log 2 of 10 maybe.
Let's say 10x. Okay? Because I'm adding here, I can write it as a multiplication problem. Isn't that 4 times 7? Yeah? So 4 times 7 is 28 equals log base 2 of 10x. 28 equals 10x. Yeah? Okay. And that's a great question, because you may see something like that. So you want to combine it to where you're having one log on each side, and then combine what they're equal to. Okay? The homework for today is going to be on page 382 and 383, 14 through 72, the even ones. You're going to need some help, so what do we have? Well, we only got about 10 minutes, so, but if you have any questions, come on up for some extra help, right?